all, so as an electronics engineer, we always need some power supply, right? So whether it be an SMPS or a linear supply, or it could be a simple regulator that is mounted on a board where you generate some voltage. So it's all DC power that you use for all your embedded boards, right? So if you are working for an organization, you do have lot of equipment in-house, and then you do lot of tests. But if you are a hobbyist, you tend to struggle for resources, especially to buy the equipment that is required. And then what happens is, because of that, you are constrained with those, and then you may not be able to uh, explore your hobbies as an electronics engineer. So these are common challenges that are faced by electronics engineers. So why I'm talking about all these is, few days back I just wanted to buy a power supply, and this particular power supply I just wanted to use at home for some of the hobby things that I work out during my idle time. So, and when I explored through several things, the cost of the DC power supply was too high. It was around somewhere 15,000, somewhere 6,000, somewhere 10,000. So I'm talking about the INR here. So in Indian rupees, it was too costly, which I could not afford that much just for a power supply, right? So instead of that power supply, we can design a small board by ourselves using small regulator and generate the required supply. So I was hesitant buying those power supplies, but I did explore a bit in the local market. So I'm specifically from the southern part of India, and located out of Hyderabad. So in Hyderabad, I just tried to find an alternate option for power supply in the local stores. So that's where I got this supply. So this supply, if you see here, I'm just trying to pull this out. So there's a simple power supply here, a very easy to use one. So you can see this doesn't have any company name or anything. It's locally available. Definitely there is some model number, and it says, you can see the specs here. So the input is AC supply. It works from 100 to 240 volts, and then the output is 3 to 24 volts at 2 amps current. So for all our home based hobby projects, this is enough, right? And then you can see here there is a knob to adjust the voltage. There is a display for displaying the DC output. So a very useful one. And you can see it comes with a AC plug on one side, and it comes with a DC jack on the other side. So I asked a store guy, if we have a board, it's very difficult to have this jack mounted, right? Either I have to cut it here and pull out the wires and solder to the board, which I don't want to disturb this particular new one. So he gave me a jack which is easily available, where you can plug in and you get two wires. So a very simple setup, right? This entire thing cost me around 1250 rupees INR. A simple setup. Even if I can use this for some 1 year or 2 years, example, just as an estimation, it's very useful, right? Worth the money that we have bought. So just try it out. Why I wanted to make this video is so if you are a hobbyist and you are trying to do lot of home-based projects out of your own interest, you can just try these options. Some of the people I have seen, they use that AC to DC converter based supplies, where it has options of 5 volts, 12 volts, 24 volts, which is also costing around 3000 4000 rupees. But instead of that, this kind of supply is a very useful one. Like wherever you stay, I can say in India, you can just check with your local electronic store to find out this kind of supply. Now we'll just try to power on and see what's the voltage that is being read by our multimeter, and whether it is actually working properly or not. Let's just try to read the voltage. So you can see here, this is the adapter power supply, and you can see the knob clearly here, the rating, and then we connected it to a multimeter. So now what we are trying to do is we are just trying to power up. Okay, now the power up, I'm just trying to turn the knob on. You can see the reading shows 4.83, and multimeter shows 3.9. so definitely there is some variation. So this has claimed a lower voltage of 3 volts. Let us see what it reads. So this is saying 3.43, and the multimeter shows 2.841, and this is the major point here. So while using these kind of adapter based power supplies, you don't get that accuracy. And again, what happens is when you try to use these with loads, there is no guarantee that the voltage remains same at high currents especially. So you can see here we are just trying to pull the voltage up. So like example, now it reads 10.5, and you can see the multimeter reads 9.11. so multimeter could be also problematic here. So you can see we have gone up to 25.6 volts. So if you actually read the specs, this particular model claims up to 24 volts. So the reading shows 25.6 and 22.44. So considering these scenarios, right, when we are using these kind of power supplies, there is definitely a variation that is seen with respect to the output voltage. So just don't go by this reading blindly. Try to use a standard multimeter. So we are using a standard multimeter here. So and this is tested with other things. So ensure that you have a good multimeter in hand. Don't use another local multimeter to measure a local power supply, which could be a catastrophic situation, and you might end up giving 5 volts instead of 3.3 volts and burning your board or something. So ensure these points. But one thing overall is that this power supply could be a cheap one, but useful one, which can be used for small testings, hobby projects at your home. Hope you find this useful. So we have shown the part number as well. If you want, just try it out over Google and see what are the specs. And another important point is if you have any other power supplies, cheap power supplies that you tried, and if you want to suggest, please post in the comments. Thank you.